David.
Our project, we've built what we call a Wi-Fi mobile. We started with an RC car that we bought from Radio Shack for about $25, and we totally stripped it of its controller, basically all of its electronic parts, and we put in an Arduino, which we programmed, and then we bought what's called a Wii Shield, which gives the Arduino Wi-Fi capabilities, and that allowed us to do further cool things with it, which I will explain in just a second. So this is our prototype for what we're building. This is our future product. Stay tuned. So the concept is an RC car that has a server, and that server serves a website. It's controlled by an Arduino with a Wii Shield. It allows a user to control the car through the website. The website can be accessed anywhere in any wide area network. The car has 4 sonar distance sensors on it, so that it never hits obstacles. It avoids obstacles, walls while driving. It has 2 modes. It has a manual mode and automatic mode. Manual mode means that the user can just choose on the website, I'd like to go forward, I'd like to drive backwards, and the car still avoids walls and makes sure if you command the car to crash into a wall, the car does not do that. And while driving automatically, it basically just randomly moves and avoids walls, whatever it has to do. And I guess one future application of this is it could be used for reconnaissance applications. Here's a picture of, these are the sonar sensors. There are 4 of them on the car, one in front, one in back, and 2 on the sides. This is the Arduino. This is the Wii Shield on top of it. This red light means that when the picture was taken, the Wii Shield was connected to the local area network. Here's our circuit board, some H-bridges, more sensors, piezoelectric speaker so that the car can honk. The user from the website can choose to drive the car forward, backwards, or stop, can align the wheels right, left, or straight, can choose speed, high, medium, low, can honk. It's not that loud. We're still working that out. He can choose to update the sensors because the sensors they can only update every so often. But if the user wants to get the most updated information, he can ask the website to provide him with that, and then the user can release control, putting it into automatic mode, and while in automatic mode, can choose to regain control, putting it back into manual mode. Here is the website. It's kind of hard to see, I guess, but here are all the buttons: release control, high, medium, low. It tells you the current speed you chose was low. The car status is stopped. Wheel orientation is straight. And here are the distances that the different sensors are reading. And now Ephraim is going to talk about the...
All right. So I just want to talk about the circuitry over here in our project. So in the center of it all, as you can see, is the Arduino, which is doing all the controlling on this car. What we have is a 9.6 volt source, which is the battery. That's just the battery that came with the car. Now, of course, Arduino does not run on 9.6 volts. It actually runs on 5. I heard that you could run it on a higher voltage, but I realized the hard way that the sensors do not run on 9.6 volts. We went through a couple of those. So to get this differentiation between a 9.6 supply and a 5 volt supply for the rest of the system, we just use this power regulator set to go from the 9.6 to 5 volts. So actually, the motors of the car still need the high voltage of 9.6 to run, but all the controls for the system are running on 5 volts. And the Arduino is being powered by the 5 volt supply. So what we have here is that here's our 4 sensors, which are powered with the 5 volts, and they are actually sending input and output to the Arduino on the same line. The way the sensors can be set up is that the pins are first designated as output pins. You send a message to the sensor, send out a ping, find out what's going on out there, and then switch to an input. Take back the time delay to see how long it took to get from that input to that output. Gives you a reading. And the motors are controlled through 2 H-bridge circuits, which I'll get to in a second. So they have a 5 volt control which is being controlled by the Arduino, and 9.6 supply, which is actually going to be fed to the motors in the case that the control says feed it to the motors. The Wii Shield is just mounted right on top of the Arduino, uses the same power supply. That's not too complicated. Now, when the car is in the automatic mode, these are actually the sensors and the motor controls are going to be communicating through the Arduino regardless of what's coming in on the Wii Shield because it's in automatic. We want the sensors to update where am I in relation to the walls and control the motors based on that. That's our software doing that in the case of automatic mode. Now, the H-bridge circuits, we first wanted to build them on our own. We're having some difficulty with that. So in the end, we bought them. They're basically just set up like this. You have your high voltage, and these pin 1 and pin 2 are the outputs from the Arduino, and they're just controlling this 4 set of transistors. So in a case that pin 1 is high and pin 2 is low, let's say, the current will be flowing down through this way. This one low will pull this up. It'll allow current